Alright, y'all, this is the backside. A skydiver is standing waiting near an open cockpit, 4,410 meters up. Displacement. Leans over and free falls. Free falls. That tells us that we're falling down. If we look at our diagram, acceleration due to gravity is going to be this direction, but if we free fall, our initial velocity is 0. We're just falling with no additional or any previous velocity downward. Okay, that was a killer for a lot of people, remembering that. Parachute doesn't deploy as they plunge into the water with a velocity of 294. So that is actually a final velocity. That's the velocity we hit the water with. Alright, so we're speeding up as we hit the earth. Free falling for 30 seconds, that's time. So, 4, 4, 10. Initial velocity is 0. 294 is our final velocity. We're looking for our gravitational acceleration, and the time was 30 seconds. So we can pick any equation we want, basically, because we have everything. There's nothing we can eliminate, so why not just pick the easiest of them all? So VF equals VI plus AT. We're going to substitute in. VF is 294, VI is 0, plus A right here. So that goes away. We can just eliminate that. 294 equals 30A divided by 30. And 9.8 ends up being our result. And if you recall, 9.8 is Earth's gravity. Moving on. Number 5, rocket-powered sleds are used to test the human response to acceleration. If a rocket-powered sled is accelerated from rest, rest means that the initial velocity is 0 right there. 444, that's our final velocity, over 406 meters, that's distance. What is the acceleration and time? We want A and T. So we got to figure out what we can do here. VI was 0, VF is 444. Displacement is 406, and it wants both A and T. We're a little bit stuck here because every equation has acceleration in it. So logically, we need to find A first. So let's treat this as if time is eliminated. Anything with time goes away. We're going to use this third equation to solve for acceleration. Then we'll have to solve for time. So, using that equation, 444 squared, since it's VF squared, equals VI squared plus 2AD. Well, here, our VI is 0 squared because we're coming from rest, plus 2. A is what we're looking for, right? And our displacement was 406. So, 444 squared equals, this term goes away because 0 squared is still 0, and now we just have 806A. So from this, 444 squared is going to be 197,136 equals, ooh, did I say 806? Oof, 812, my mistake. 812, oops. In any case, that'll be 812A divided by 812 divided by 812, and that simplifies to 1. Here, A is going to leave us with 242.8. That's not all. Now that we have A, which is 242.8, we can now solve for T. We can pick any of the 3 equations. So for T, to solve for that, we are going to go with the first equation. It's going to be real easy. VF equals VI plus AT. We can solve for time. We have final velocity, initial velocity. So, given that information, we're going to take VF, which is 444, equals VI, which is 0, plus A, which is 242.8, and we're solving for time. That goes away. We just have to divide both sides by 242.8 in this case, and that's going to result us with, I believe, off the top of my head, about 1.82 seconds. Let's go on to our last problem now. Oh, I almost forgot. We're speeding up, so V is essentially 0. Acceleration is this way. We're going to speed up. here for number 6. It was once recorded that a Corvette left skid marks that were 290 meters in length. 290 meters is the length here, assuming that that Corvette skidded to a stop. Skidding to a stop means our final velocity is going to be 0 with a constant acceleration of 390. Well, there's some information here. Due to the brake's friction, that tells us it's negative. We're slowing down with that acceleration. So that's A, but it's negative, so it'll be negative 3.9. 0. Determine the starting speed. We're looking for VI. We don't need time. So given this setup, we're going to pick the last equation. So VF squared is 0 squared equals VI squared plus 2 times our negative 3.90 acceleration times d of 290. Going from there, 0 squared is just 0, VI squared is what we're looking for, and this over here becomes negative 2262. Alright, we want to get VI by